In this lesson, we are going to look at what is meant by non-uniform acceleration. Non-uniform acceleration is when the increase or decrease in velocity of an object over equal interval of time is not constant. Now let's look at this example. This car was traveling at a velocity of 5 meters per second at time t equals 0. 1 second later, its velocity increases to 7 meters per second. And another second later, its velocity reached 10 meters per second. And then finally, after 3 seconds, its velocity is 15 meters per second. As you can see, the increase in velocity is not constant over equal interval of time. Let's calculate his acceleration using the formula final velocity minus initial velocity divided by time taken. If we substitute the numbers, the final velocity is 7 meters per second and the initial velocity is 5 meters per second, divided by the time taken of 1 second. We get the acceleration to be 2 meters per square second. Similarly, we can compute the acceleration when time t equals to 2 seconds. Now the final velocity is 10 meters per second and the initial velocity is 7 meters per second, divided by the time taken of 1 second. Now we get the acceleration to be 3 meters per square second. Likewise, for time t equals to 3 seconds, the acceleration is computed to be 5 meters per square second. As you can see, the acceleration is not constant. If we plot its velocities of 5 meters per second, 7 meters per second, 10 meters per second, and 15 meters per second respectively, we get the velocity time graph. It is a curve. Now, how do we get the displacement time graph? As we learned in previous lesson on uniform acceleration, we will need to calculate the area under the velocity time graph to get the displacement for each second to plot the displacement time graph. Take note that this car did not start from rest, so the velocity at time t equals 0 is 5 meters per second. The velocity time graph therefore does not originate from 0, but its displacement at time t equals 0 is still 0, so the displacement time graph starts from 0. Just as in the case of uniform acceleration, the gradient to the tangent to any point of the displacement time graph will give the instantaneous velocity. The gradient to any point on the velocity time graph will give the instantaneous acceleration. The area under the velocity time graph will give the distance traveled or displacement. Now let's look at another example. Assuming that this time the car starts from rest, increase its speed very rapidly to 11 meters per second after just 1 second, and then to 16 meters per second in another second, and finally reaching 17.5 meters per second in the third second. If we compute its acceleration by substituting the final velocity and initial velocity at each time interval, we will see that its acceleration was 11 meters per square second and then dropped to 4 meters per square second and finally only 1.5 meters per square second. This means the car is traveling at increasing velocity but at a decreasing rate, so its acceleration is non-uniform and decreasing. If we plot the velocities on the graph, we will get a convex curve for its velocity time graph as shown. And by computing the area under the velocity time graph, as shown in previous examples, we will get the displacement time graph. Hence, take note of the velocity time graph for decreasing acceleration versus velocity time graph for increasing acceleration. In both cases, the displacement time graphs are upward sloping curves because the object's velocities are still increasing and hence its displacement is still increasing. In our next module, when we learn about falling objects, you will discover that objects that free fall in the presence of air resistance will have velocity time graph as this, where they accelerate at decreasing rate. Now here's an assignment for you. In previous lesson, we learned that uniform negative acceleration or deceleration has a downward sloping straight graph with negative gradient because the car reduces its velocity equally over equal interval of time. Take a few minutes to ponder over What would the graph be like if an object is decelerating non-uniformly at an increasing rate? This is what is meant by decelerating non-uniformly at an increasing rate. Say this car was traveling at 30 meters per second, and then it starts to reduce its velocity, but the rate of reduction gets bigger over equal interval of time. What do you think its velocity time graph and displacement time graph would be like? Then also give some thought to the scenario where an object is decelerating at a decreasing rate. That means if the car is initially traveling at 30 meters per second, when it reduces its velocity, the rate of reduction gets smaller. In our next lesson, we are going to learn how to solve past examination questions that involves graphical analysis of objects' motions.